continuation of a previous lecture. Now today we discuss about one very important topic, which is linear fractional transform. So here we write a linear fractional transform. Fractional transform. And this one is also known as a what? Bilinear transform. Bilinear transform. Bilinear transform. And this one is also known as a what? This one is also known as a Mobius transform. Mobius transform. Mobius transform. So linear fractional transform or bilinear transform or Mobius transform, all they have a same meaning. So a transform, what is the definition for this one? A transform of the form W equal AZ plus B divided by CZ plus D, provided what? AD minus BC does not equal to C. AD minus BC means A into D multiplied minus B into C does not equal to C. So a transform of the form W equal AZ plus B divided by C into Z plus D is called definition. This way the definition, we write the definition, is called linear fractional transform. Linear fractional transform. Linear fractional transform. Now if we try to analyze this one, means you may also write this one in this form, means W equal what? W equal AZ plus B divided by CZ plus D. So if we multiply this one and provided what? AD minus BC does not equal to C. A into D minus V into C does not equal to C. So if we multiply this one by this one, then this becomes C ZW plus DW minus AZ, this one minus AZ minus B equal to what? C. So if we write this one is AZW, here we write AZW, this one is AZW plus BZ plus CW capital C plus D equal to C. Then you may closely observe, you closely observe, A is replaced by what? C. B is replaced by the minus A. D is replaced by the C. And B minus B is replaced by the D. Now, what will happen here? This one is the AD minus BC does not equal to C. Now, what is the value for A? A become what? Minus A become what? In place of A, we write what? Minus B. And in place of a D, what we write? In place of a D, we write a what? In place of a D, we write a C. So minus BC plus AD. So in place of a small a, we write a B. So in place of a minus, in place of a B, we write what? In place of a B, we write a D. So this become what? AD minus BC does not equal to C. Means what is the equivalent form of this one? Equivalent form of W equal AZ plus B divided by CZ plus D. This become what? A ZW plus BZ plus CW plus D equal to 0. This one is called what? This one is called linear fractional transform. Provided what? AD minus BC does not equal to 0. Means this one is equivalent to this one. So here, why this one is called bilinear transform? Bilinear transform. So this one is a what? This one is a linear in term of a z, and also this one is a linear in term of w. So this one is a linear in term of a z and linear in term of a w, and this one is equivalent to the w equal az plus b divided by cz plus d. So this one is also known as a what? Bilinear transform. This form is also known as a linear fractional transform or bilinear transform, and both are equivalent. Either we write in this form or we write in this form, both have a same meaning. Why this one is a bilinear transform? Because this one is a linear in term of a z, and also this one is a linear in term of a w. Now, if we try to analyze some more concept, means either we write in this form or this form, both have a same meaning, both are the what? Bilinear transform. Both are the bilinear transform. So now if we try to analyze this one, we try to analyze the bilinear transform. How do we analyze the bilinear transform? Means if we write a w equal az plus b divided by cz plus d, provided that a into AD minus BC does not equal to 0. AD minus BC does not equal to 0. Now, suppose C equals 0. Then what will happen? Then W become what? W become, if C equals 0, then W become A by D Z plus B by D. And here C equal to 0, then what will happen? AD does not equal to 0. A into D does not equal to 0, this means A does not equal to 0 as well as D also does not equal to 0. A does not equal to 0, D does not equal to 0. Then what we conclude? We conclude that bilinear transform, this one is a bilinear transform, or this transform bilinear transform, in case of this one C equal to 0, transform does not contain any constant function. Constant function means if A does not equal to 0, D does not equal to 0, then always there is a presence of this term. So you cannot express this one as a constant function, means W equal a constant, W equal 3, W equal 4. You cannot express the bilinear transform. If there is a bilinear transform, you cannot express the transform as a constant function if C equal C. If C does not equal to 0, then what will happen? If C does not equal to 0, then what will happen? If C does not equal to 0, then now we try to write this one in a special form, is some mathematical operation we perform here. W equal what? We multiply in the numerator and denominator by the C, then this becomes ACZ plus BC, and divided by C into CZ plus D. Means in the numerator we multiplied by the C, and in the denominator we also multiplied by the C. And here we add what? Here we add AD and subtract the AD. And now we combine this term with this term. Now this become what? This become W equal ACZ, A outside, then this becomes CZ plus D divided by what? C into Cz plus D. Means this term plus what we write here? BC minus AD divided by C into C. Here we write 1 upon Cz plus D in this form. So here this one cancel out. So what we write here? W equal what? W equal, here we write this one cancel out, then this becomes A by C plus BC minus AD divided by C into 1 upon Cz plus D. This one. So now if we closely observe this expression, then what we conclude that? We conclude that what? Here, we try to write here and try to explain what will happen. Now, here, if we write this one is a W1. W1 equal what? W1 equal 1 Cz plus D. Cz plus D. Then W equal what? W2 equal 1 upon W1. 1 upon W1. And this become what? Here, suppose BC minus and W3 equal what? P into W2. W2 and P equal what? P equal VC minus AD divided by C. And here W4 means W3, then W4, W equal what? W equal A by C plus what? Plus W3. So if you closely observe, this one is a what? This one is denoted by the what? This one is denoted by the W1. This one is a W1. Then W2 equal what? 1 upon W1. This become 1 upon W1 become what? W2. And multiplied by this one, W2 become what? W3. This one, P into W2. This one multiplied by 1 upon W1 become what? W3. And W equal what? A by C plus W3. So if you closely observe, if C does not equal to 0, then the bilinear transform contain what? Contain the inverse transform, inverse transform, and this one is what? This one is a magnification, and this one is also what? This one is what? Translation. So bilinear transform contain what? Bilinear transform contain inverse transform, magnification, translation, as well as this one is what? This one is a linear transform. So, and also we, if closely observe, here if C does not equal to 0, then bilinear transform means here if we write W equal AZ plus B divided by CZ plus D, AD minus BC does not equal to 0. Here we write. So, if we closely observe, C does not equal to 0, then A by C plus this term BC minus AD, this one does not equal to 0, and this one also does not equal to 0, and C does not equal to 0, then this one is also does not equal to 0. This one also does not equal to 0. Means a bilinear transform, if C does not equal to 0, then does not express as constant function. So either C equal to 0 or C does not equal to 0. You cannot express the bilinear transform as a constant function. Means a bilinear transform cannot be written as a constant function. So this one is just some analysis of a bilinear transform. Now, if we try to find out the inverse of a bilinear transform, then what is the inverse of a means if we try to write in term of a what? In term of a W. W equal AZ plus B, CZ plus D, and what is the value in term of a what? In term of a W. In term of a Z, sorry. So here W equal what? AZ plus B divided by CZ plus D. Provided what? AD minus BC does not equal to C. AD minus BC does not equal to 0. Now here, if we write here WCZ plus this one multiply cross multiplication, WD equal what? AZ plus D. So if we write what? If we write the term of a Z on one side, then this becomes WCZ minus AZ equal what? Minus WD plus B. Then what is the value of a Z? Z WC minus A equal minus WD plus B. Then Z equal what? Z equal minus WD plus V divided by WC minus A. This one is a what? This one is a inverse of a bilinear transform. Means if we write W equal AZ plus B divided by CZ plus D, then Z can be written as a minus WD plus B divided by WC minus A. So if a bilinear transform is given in term of a W, you may also write in term of a Z. Means in term of a Z, and this one is in term of a W. Now, one another things in a case of a bilinear transform. There is a one implicit form. Means you can express the bilinear transform if 3 point is given in a Z plane and corresponding 3 point is given in a W plane. So what will happen in an implicit form? If we write the implicit form of a bilinear transform, implicit form of bilinear transform, bilinear transform, implicit form of a bilinear transform. So if there are 3 points, means a Z1, Z2 and Z3 in a Z plane, and there is a 3 corresponding point corresponding to the Z1, there is a W1, corresponding to the Z2, there is a W2, corresponding to the Z3, there is a W3 in what? In W plane. Then how we write this one? This can be written as a what? This can be written as W minus W1 into W2 minus W3 divided by what? Divided by W minus W3 divided by W2 minus W1 equal to Z minus Z1 into Z2 minus Z3 divided by Z minus Z3 into Z2 minus Z1. So this one is a implicit form. Why this one is called the bilinear transform? So you may express this one. So if we multiply this one by this one, this one by this one, then what will happen here? W minus W1, W2 minus W3 into Z minus Z3, Z2 minus Z1 equal here W minus W3, Z minus Z1, Z minus Z1, Z minus Z1, W2 minus W1, W2 minus W1 and Z2 minus Z3, Z2 minus Z3. So if we simplify this one, there is a constant, it's a constant with WZ. Means we equate the coefficient of a w and z from here, from left side and right hand side. Then we find the difference of a two constant, and difference of a two constant is again constant. So there is a constant into a wz plus there is a constant difference of a constant, and this one is a what? This one is a z plus difference of a constant into a w plus all the constants. Here this one is a constant, and this one is also a constant. This one is also a constant. This one is also a constant. This one equal what? C. Means we equate the right hand side on left hand side and equate the coefficient of a wz, equate the coefficient of a z, equate the coefficient of a w, and equate all the constant. So if you closely observe this one is a what? If this constant is denoted by the awz plus vz plus what? cw plus d equal to what? C. Provided what? Provided here these are the constants, and this constant does not equal to C. So this become what? AD minus BC does not equal to C. So this implicit form can be written also in a bilinear transform, because this bilinear transform also written in this form. So this implicit form is also called a what? Bilinear transform. So one thing there is a need to emphasize, if any point in a z plane map to y extended means map to infinite, or any point in a w plane tends to what? Infinite, then what will happen here? Here we consider what? Suppose w tends to infinite. W equal infinite. Here we say w equal infinite. Like this one, w equal infinite. W tends to infinite. Basically there is no any existence. So here we write what? W tends to infinite. W tends to infinite. Then what will happen in your left hand side? Infinite minus w1 divided by infinite minus w3. So limit w tends to infinite, w minus w1 divided by w minus w3 means this term, which include which term tends to infinite. We include only those terms. Here this was a constant, so I am not including this term, w minus w1, w minus w3. So if you closely observe here, w become outside, and this become what? This become limit w tends to infinite, this become 1 minus w1 upon w, and this become 1 minus w3 upon w, and this one equal what? 1. So to solve any numerical example, if any value corresponding to the z or corresponding to the w become infinite, then the ratios corresponding this one we consider what? 1. Similarly, if z tends to infinite, then we consider this term and this term. Limit z tends to infinite, then this term divided by this term become 1. So to solve numerical example, we also means take we also consider this one, this result. So now we solve a numerical example. So numerical example, there are in general there are two type of numerical example. One is a what? One is a find a bilinear transform. Second one is a if a mapping is a given, then bilinear transform, and bilinear transform is a given, then find the image corresponding to the z plane into a w plane. So there are two type of a question. So now we solve these two type of a questions. So now first we erase out this. So this one is the example. Here bilinear transformation is a given, then we try to find out the what? Image in a w plane. So what is the question? Find the image of x is a greater or equal to 2 and y is a greater or equal to 1, means this one is a given in a z plane under this bilinear transform. So what is the solution? Solution is a what? Solution w equal what? W equal 4z plus 1 upon z minus 2 minus I is a given. So w equal what? W equal 4z plus 1 divided by z plus minus twice minus I, this one is a given. This one is in the form of a az plus v divided by cz plus d. Provided what? Here ad minus BC does not equal to 0. Here you may verify this one, AD minus BC does not equal to 0. So what is the value for Z? Z equal, we know that what is the value? This become minus dW plus V divided by CW. So CW minus A, basically CW minus A. CW minus A. So dW plus V, dW plus V, CW minus A. CW minus A. Now what is the value for this one? So it will be right here. Now what is the value? Z become what? Minus T. What is the minus T here? 2 plus I. 2 plus I. W is a what? W plus what is the B? B is a 1. Divided by what? C. What is the C? C is a 1. W plus what? D. D is a minus A. What is the A? A is a what? A is a 4. So this become what? This become minus, A become 4. W minus 4. So this one is a Z. Now we equate just, this one is a very simple. Equate the real and imaginary part, then write the real part greater or equal to 2 and write the imaginary part greater or equal to 1. So this become x plus iy equal what? This one 2 plus I into W equal what? U plus IV plus 1. In a denominator this become U plus IV minus 4. So what will happen? After simplification, this become x plus iy equal 2 plus I U plus IV plus 1 divided by what? Divided by U minus V, U minus 4 plus IV. So U minus 4 plus IV. So here we equate the real and imaginary part, we multiplied by what? U minus 4 minus IV and also U minus 4 minus IV. So in a denominator what will happen? U minus 4 whole square plus V square. So if we equate the real and imaginary part, here we noted down the real and imaginary part. So if we write one more step, x plus iy equal what? 2 plus I U plus IV plus 1 and this become U minus 4 minus IV and in a denominator what will happen? In a denominator become what? In the denominator become U minus 4 whole square plus V square. So if we equate the real and imaginary part, what is the real part? What is the real part? X become what? X 2 times of U square plus V square minus 4 divided by what? Divided by U minus 4 whole square plus V square. Now what is the value for Y? Also we noted down the value for Y minus 4U minus 9V. In a denominator obviously U minus 4 whole square plus V square. So now equating the real and imaginary part, then what will happen? What is the question? X is a greater or equal to 2. So we equate what? We equate this one. We equate this one. Means x is a greater or equal to 2. So 2u square plus v square minus 7u plus 4v minus 4 divided by u minus 4 whole square plus v square is a greater or equal to what? Greater or equal to 2. So if we simplify this one, then this becomes 2u square plus 2v square minus 7u plus 4v minus 4 is a greater or equal to what? 2u minus 4 whole square plus v square. This will become 9u plus 4v minus 36 is a greater or equal to c. Similarly, we equate this one, y is a greater or equal to 1. Y is a greater or equal to 1. We say this one is a greater or equal to 1. Greater or equal to 1. Minus 16, sorry. Minus 16 is a greater or equal to 0. So these are the two planes. These are the two planes. This one is a corresponding to what? This one is a corresponding to x is a greater or equal to 2. This one is a corresponding to y is a greater or equal to 1. So this one is a very simple. Just write a bilinear transform, write the z in term of x and y, write the w in term of a u and v, equate the real and imaginary part, then simplify, then we find a what? Then we find the image of a xy plane in a. So this one is a problem. Means what is the problem? There is a need to find out a bilinear transform under the mapping of a z plane to a w plane. What are the points in a z planes? 0, 1 and infinite. And what are the points in a w plane? Minus I, infinite and 1. And how we find the solution of this one? Solution of this one, just we write the implicit form of a what? Implicit form of a bilinear transform. What is the implicit form of a bilinear transform? W minus W1 into W2 minus W3 divided by W minus W3 into W2 minus W1. This one equal Z minus Z1 into Z2 minus Z3 divided by Z minus Z3 into Z2 minus Z1. It's very simple. Just put the values of a W1, W2, Z1, Z2, Z3, W1, W2 and W3. So here, what is the value of a W1? W minus, what is the W1? W1 is a minus I. So this becomes minus I. W2 is a what? W2 is infinite. So infinite minus W3. What is the value of a W3? W3 is a 1 divided by what? W minus W3. W3 is a 1 into W2 minus 1. W2 minus W1. W2 is infinite minus W1 plus I equal what? Z minus, what is the Z1? Z1 is a 0. So Z1 is a 0 and Z2 is a what? Z2 is a 1, Z3 is a infinite divided by Z minus Z3. Z3 is a infinite. Z3 is a infinite and what is the Z2? Z2 is a 1 minus 0. So if we simplify this one, as earlier we discussed, if there is a term of infinite, then we saw that the limit of this one become what? Limit of this one become 1. So directly here we cancel out these terms because earlier we mentioned this one is a property. If there is a new term in a numerator, there is a means of one term tends to infinite, then the limit of these two terms become what? 1. And limit of these two terms also become 1. So if we simplify this one, then here you closely observe z, because this one is a z, this one become 1, and in a denominator this one is a 1. And if here we closely observe, this one is a w minus minus become plus, w plus I divided by what? W minus 1. So this one is a bilinear transform. If we write a z equal w plus I divided by w minus 1. So this one is a bilinear transform. This one is a bilinear transform which maps each point of a z plane into a w plane. So in general there are two types of a question. First one is a find a bilinear transform, and second one is a bilinear transform is a given, then find the image of a z plane into a w plane, and vice versa, find the image of a w plane in a z plane. So this one is all about this lecture. In the next lecture we discuss about conformal mapping, which one is related to the what? Related to the bilinear transform. Thank you for watching my video.